Welcome back to Geometry Chapter 8, Section 1 in this book. What we're talking about is similarity. Last chapter we talked about isometries, which is where shapes are exactly the same shape and size, but we moved it to other places and learned all about that in Chapter 7. So now we're going to talk about things that are similar instead of a versus a transformation. Similar things have the same shape but different sizes. Now, before we get into that, we're going to review something you learned in probably pre-algebra and algebra 1, ratios and proportions. So, a ratio is something like this. A is to B. You can also write it this way, A is to B. But remember, B can't be 0 because it breaks the world. You cannot divide by 0 because it violates the law of conservation and the law of conservation of mass and energy. So we can't break the laws of science. We can't divide by 0. And I explained that in another tape. Alright, so instead of doing it like how maybe you learned it in pre-algebra or algebra, they give you a few tricky questions to start off with. Like this one is 12 centimeters is to 4 meters. Well, notice they don't have the same units. So if they have different units, step 1 is to make them the same. Now the book shows you one way to make the units the same. I want to show you another way. It's a better way. And it's the way that you can change the units of anything. It works in chemistry when you're starting to change from moles to atoms. Just anything you want to convert, you can do this way with a conversion factor. How you do it, we're going to convert the 4 meters to centimeters to make it the same. So what you do is first you write down what you know. What we know, what we're starting with is 4 meters. What we're going to convert is 4 meters. Then you draw railroad tracks. And sometimes you have to add to the tracks because you have to change it to one thing before you change it to something else. But this one's an easy one. And the reason why you want to do these railroad tracks and not parentheses the way some books show is because the parentheses are messier and kids end up messing up because of the parentheses. The nice, neat lines work better. Okay? Then you write the unit of what you know down on the bottom. And you write the unit you're changing to on top. And then you think about the relationship mathematically of them. That there is 100 centimeters in 1 meter. So we write that relationship down. So, and then you cancel out. If this is like the numerator and that's the denominator, and if you have the same thing in the numerator and the denominator, you get to cancel it out. So you cancel out those units, leave the number. Any number on top gets multiplied, anything on bottom gets divided. So it's 4 times 100 divided by 1. But if you multiply or divide by 1, it's that thing. So you can really skip the ones. So really it's 4 times 100 is 400. And the unit that was left was centimeters. So now we write our ratio correctly. 12 centimeters to 400 centimeters. And this is not reduced. So if you have something that's not reduced, they want you to reduce it. Now if you didn't know that this reduces to 3 over 100, you can do it quickly on your calculator. Just put in 12 divided by 400 and it will write a decimal. Then you hit the button that says math, which I think is funny because aren't they all math? And then enter twice, enter, and it will give you that answer. It will your calculator will reduce fractions for you. Wouldn't that have made 6th grade easier? Alright. So the other thing is, because this is a metric system, there's actually an easier way to do it, and it's this. King Henry's daughter bakes delicious chocolate muffins. King is kilo, H is hecto, D is deca, B is basic, little d is deci, little c is centi, little m is milli. So you can remember that all the e's go together. Deci, centi, milli, and deca is the big one. So what you do is you start from where you are, and we were in the basic unit of 4 meters, and then you just see how many frog jumps it is to where you want to go. And we want to go from basic to centi, from meters to centimeters. So it's 1, 2 frog hops. So you take your decimal point and make it hop that many places in the same direction, and we can tell it's 400. And this is why metric is better than English for math and science. I used to say it was better for everything. And when they make me queen of math, then at midnight we're all going to metric, because using these two systems is too confusing. But now I've decided we really just need to use metric for science, and we need to use English for everyday living, and stop mixing them that way. I think that would straighten it out, because cooking with metric is not all that great. I got a metric cookbook from Nancy Bakes, and I don't like the metric thing. I like the tablespoons, the cups. I like the English. All right, so let's try this one. 6 feet over 18 inches. That doesn't work. 6 feet is to 18 inches. We're going to change the 6 feet into inches. And this is not metric, so we can't frog hop. So we put what we know on top, the unit of what we know on bottom, the unit of what we want to go to on top, and the relationship. The relationship between 12 inches and 1 is that there's 12 inches and 1 foot. And if you ever did a Becca homeschool, it was stop, kaput, 12 inches in a foot. Did you learn that in your Becca first grade? Okay, so the feet cancel out. You multiply on top, divide on bottom. So 6 times 12 is 72, divide by 1 is 72. So 72 is to 18, and then we can reduce that, but it's actually just, it goes into it 4 times, so it's 4 is to 1. If we down our calculator, it would just say 4, but we want it to have a denominator, so we put an understood 1 down there. All right, so here's a problem with it. Here we have a rectangle, and we know the perimeter is 60. And we know that the formula for perimeter is 2 times the length plus 2 times the width. Notice I wrote them in cursive. By tradition, you do, either cursive or italicized if it's a printed book. So, and they tell us that the length is, the ratio of length to width is 3 to 2. 3 to 2. So the length to the width is 3 to 2. You read that as 3 is to 2. Well, we can put this in our formula. That the length is 3x, the width is 2x, and it's going to equal 60. Multiply it out, 3 times 2 is 6, 2 times 2 is 4, add them together, 10x, divide both sides by 10, x equals 6, and then we put it back in up here. 3 times 6, the length is 18, 2 times 6, the width is 12. This is a classic math problem. They love this everywhere, so make sure you know how to do that one. Here's another one. They tell us the 3 angles of a triangle are of the ratio of 1 to 2 to 3. So we say 1x, 2x, 3x. And we know if you add the 3 angles of a triangle, they equal 180 degrees, so we can solve it. Understood 1x plus 2x plus 3x is 6x. Divide both sides by 6, and you get x equals 30. So this triangle, this angle is 30, that one's 60, that one's 90. 30, 60, 90, and that's a very classic triangle. When we get to a trig, I'll explain to you why it's considered a classic triangle. Okay, so here's another one. We have 2 similar, that's the symbol for similar. It's like the symbol for congruent without the equals underneath, just the little tilde looking thing in Spanish. Okay, and we have, so that means they're the same shape but different sizes. We have a big one and a little one, and they're right triangles. This one has a side of 8, and this one has a side of 3, but they do not correspond. And we're also told that the big triangle to the little triangle, its ratio is 2 to 1. This one is twice as big as that one on everything. Now, you can do this in your head, but I want to show you how to do the math in case you couldn't, for another one where you couldn't do it in your head. So you're going to say, 2 is to 1 as x is to 3. And I can cross multiply and solve for this x. 2 times 3 is 6. 1 times x is x. So x is 6. And I know over here that this side is 6. Now, if I told you it's twice as big, you know twice as big of 3 is 6. But anyway, so now let's do y. So this one is 8. So this one is, you already figured it out, 4. But if we didn't know that, we could cross multiply and figure it out. On this side we would have 2y, on that side we have 8, divided by 2, divided by 2, y equals 4. 8 divided by 2 is 4. Now, what I just did was cross multiply solve for x, but they haven't taught it to us yet. So they really want you to do that one in your head. So this is, if you have fractions on both sides of an equals, then the ones here are called the extremes. The ones here are called the means. The means. Now, and that's gonna be important later, but not now. There's gonna be some things you can do. This is what you already learned that you could do. You can do what they call as cross product, which is really cross multiply. So you can multiply across the equals. A times B on one side, bring down the equals, B times C on the other, and I always write the arrows. It helps remind me what I'm doing. It works when you have fractions on both sides of the equal. So another thing you're allowed to do is flip it. If A is to B as C is to D, then you can flip it upside down and it's still true. B is to A as D is to C. It's like down here. We could say that they were 2 to 1, or we could say 1 to 2. It doesn't matter. It just means this one's twice as big as that one. Okay, so here's a problem, a cross multiply problem. You have fractions on both sides and an unknown. Step 1, draw your arrows. Step 2, multiply across the equals. 4 times 7 on one side, bring down the equals, 5 times x on the other. 4 times 7 is 28, 5 times x is 5x, y is x not alone, it's being multiplied by 5. We divide both sides by 5, those cancel out. X equals 28 over 5. And you know we like improper fractions, we don't like to properify them. Here's another one. It can even be fancy like this. Doesn't matter. 3y on one side, 2 times y plus 2 on the other. Don't forget the distributive property, 2y plus 4. So 2 times 2 is 4. Y is y not alone. Well, first we have to get our y's together. We have to gather up our terms. Subtract 2y from both sides. And 3y minus 2y is y. And what's left over here is a 4. So 5.